plus 1 times x plus 5. And you're supposed to find that a and b. I'm going to tell you the easy way I've only seen it in one textbook of how to find that works on the really easy ones. And it even works on the harder ones as far as it won't lead you astray, but it will find everything. We got to solve that algebraic equation for a and b. But big stars by this. You're now into the big leagues. You multiply everything by the common denominator. So we get a x plus 5 plus b x plus 1 equals 1. You multiply it. You need to write down what I did. I multiplied everything by the what? Common denominator. I multiplied both sides by the common denominator, and that's what it becomes. Write what I did. I multiplied both sides by the common denominator. Now, don't write down what I'm about to do. But I'm going to show you how it's worked in the textbook. You distribute the a out, and you get ax plus 5a plus bx plus b equals 1. Does everybody see how there are no x's over there? That tells me that ax and bx has to equal 0 x's. Because you don't have any x's over there, do you? Which also tells me then that a plus b has to equal 0. Now, notice that's going to make a constant, and that's going to make a constant. So 5a plus b has to equal 1. And then you solve the system. Now, I'm going to go ahead and tell you this one's easy because you only had 2 fractions. That'd be a pretty easy system to solve, wouldn't it? Okay? That's how it's taught in the textbook. And on some of them, you do have to do all this work. But I'm going to show you a way to avoid that work. You put stars by this. You put, Mr. Evans tried to save me when I got to college. Mr. Evans is going to help me be able to do something and look smart in college. And if your professor's doing one of these and you're polite about it, you might want to give him a hint when he starts doing all this stuff over here. Because there is a better way. And this is one of those, it is a better way that you better write down. Because unless it's somebody that learned calculus 30 years ago, they don't do it this way. That's in all the chunk textbooks of today. But if you go old school with Stewart or Lighthold, they'll tell you a better way, or Thomas and Finney. Make x equal -1. I picked that out because what's -1 plus 1? -1 plus 1 is 0. So what's 0 times b? 0. I put a -1 here. I'm going to get 4a equals 1, a equals 1/4. I just figured out a without doing a lot of work. I could have done that in my head. Then I'm going to do it again, but this time I'm going to make x equal what? -5. Because if I make x equal -5, what's going to happen to that? Yeah, that's going to make that 0, and I'll get -4b equals 1. Okay, Mr. Evans made a chunk problem. It does not always work out to where it's just a positive negative like that. This is just because I made it up, and it's not a very difficult one. But there's what b equals. That little trick, on some problems, if you have an A, B, C, and a D, you may be able to only find A and B using this trick. But you got to realize when you do that, if you have an A, B, C, and a D, you're going to have 4 equations with 4 unknowns. it sure would be nice to eliminate two of those unknowns before you ever get started. You always use this to eliminate as many of them as you can. And this will always get rid of a few of them. Okay? This is the way to find the A and B values that you need without doing massive amounts of work. Especially if it's an A, B, C, and a D. Okay? Because can you imagine having 4 equations over there and 4 unknowns and you don't have a calculator to work it and you have to solve it? All right? You want to know this. If you can carry anything with you to Calc 2 in college from in here that will save you, it's knowing how to do that. All right? And if, like I said, if you have an old teacher, but if you have a young professor, he may not do this. He'll just say, oh, everybody just solves a system of equations. They have a whole class that teaches you how to solve systems of equations, so you're supposed to know how to do it. But there you go. Now, once you know the A value, and once you know the B value, then you know that's going to give you a 1/4 natural log of x plus 1. Yeah, you don't even have to have my help to integrate that. You get 1/4 natural log of x plus 1 minus 1/4 natural log of x plus 5 plus a c on the end. And then, if you look at the back of the book, it's probably have this, 1/4 natural log x plus 1 over x plus 5. Let's see, that's probably how the answer would look in the back of the book. Remember when Euler went on the mountain? He brought back the laws on the platinum sheet. Just use that law. And this whole system has a name. When you have a denominator that will factor, and you don't already have UD, please don't think that all fractions are this, because you're hoping you already have a DU in the top. But if you don't, and you have to start creating the two separate fractions that would add together to give you that, this is called partial fractions. This is integration with what's called partial fractions. Okay? And if you integrate using partial fractions, the best thing I can teach you is this right here. This just saved you having to do all this that I didn't even finish. I mean, you'd have to do negative, negative, and work it out. No, you don't want to do all that. You want to use this little shortcut. Especially on the simple ones, because it's always going to give you all the values for A, B, and C, or A, B, C, and D on the simple ones. And notice I keep talking about how you can have more fractions than just those two, because I know that's going to happen when you get to college. All right. And this is not in the section that we're working on now. None of them are this. But this is what happens at the next level. If you're not learning these, you're going to have a hard time when you get to these partial fractions. Notice all the algebra over here? See all that algebra? Yeah, the biggest problem with these is all the algebra to get the A and the B value. The integrals are easy. Look, I mean, you can't beat that for easy integrals. The problem is getting the A and the B value. Okay? Accurate? Okay, so if you had this, is it a plain old simple U in the denominator, DU in the numerator? But what is true about that denominator? It will what? It will factor. What does it factor into? It factors into 1 here, x plus 4, x minus 1. I'll go ahead and put the dx there. Is everybody okay? It factors into that. So far, so good. And you already realize that's going to be a over x plus b over. It doesn't matter which order you put them in, it'll still work because you're adding. Now, see if you can find the a, b, and the c value. That's algebra. You find the a, b, and the c value using algebra. Algebra 1, algebra 2, solving an equation, solving a system. So since Mr. Evans solved for me, tell them it's algebra 1. It is solving an equation. See if you can find the a, b, and the c values. Because if you can find the a, b, and the c values, the calculus is easy. LSU's Calc course this semester, or last semester, for Calc 1, the final exam was 40% of your grade, and you had to take the final exam in the professor's office or in the area outside his office. You couldn't just take the final exam online. 40% of your grade was 4 questions. So every question was 10% of your grade. Yeah. And some of them, if you had an A or a B, he wanted to, actually, he would sit there and watch you take it and ask you questions about it, and you were supposed to talk to him about what you were doing as you took it. And then, of course, for people who had D's and F's, he just stuck them out there in the hall where to make sure they weren't cheating and gave them their 0 on the test, and, they either failed the course or made a D. That was kind of interesting how he did that there. Okay, so yeah, you get A times x plus 4, x minus 1, plus B times x minus 1, plus C times x plus 4. So what's the first thing I'm going to do to work this? I'm going to make x equal 0. Yeah, if I make x equal 0, I instantly eliminate this one and what? This one. And I get b equals, a equals negative 1/4. Is that what y'all got? A equals negative 1/4? Put 0 in there, you get 4 times negative 1, you get a equals negative 1/4. What are you going to do after you make x equals 0? What are you going to do? Make it equal negative 4.
Wait, how do you find?
Put a 0 there. Put a 0 there. Negative 4 times a equals 1. A equals what?
So why does that work? Never mind.
Okay, put negative 4 in there. This one and this one becomes 0. And your b value is going to be negative 4 times negative 5, so that's going to be 20. So b is going to equal 1/20. Because you're going to make negative 4, negative 5, yeah, b equals 1/20. And then what are you going to make x equal for the last one? You're going to make x equal, 1. Because I'll make that 0, make that 0, and you get c equals 1/5. And then once you get the a, b, and c values, you can almost just integrate that right there in your head. You know the a value is going to be negative 1/4. Well, I hope you're doing something math related right there. What are you doing? Mr. Evans up here bleeding his math heart out. Yeah, I'm the last math professor that's gonna care. No one after me is gonna care. I am it. I am your last hope for the F. And that's what you get, see? And those are called what? Partial fractions. This is considered big boy, big lady, serious woman work. Right there.
The dx outside of the square root?
Yeah. Make sure that's right. Yeah, that's right. Minus 2x. Okay. The last problem on the final exam last semester at LSU Baton Rouge for Calc 1, not Calc 2, Calc 1, was a problem that made you think a whole lot just to get to there. It's about 10 minutes of work. Good fight, and you had to know the equation of a circle on your own. You had to know a formula that they had taught you, which I put the numbers in the formula for you. You had to take a derivative that went in that blank right there, and you had to be able to integrate that to finish the problem. That's what you had to be able to integrate to finish the problem right there. And that's one big square root with a dx outside of it. And that was 10% of your grade. So if you got to right there, you still had a big chunk left to do. I mean, there's a lot. And then after you integrated it, you had to do the algebra that you were supposed to do with the integral. But that was just what, in the middle of the problem, that's what it simplified to. It simplified to that integral. You are supposed to be able to do that integral with what is in 5.2 Light-Hold. 5.2 Light-Hold is supposed to teach you enough to do that. R is considered a constant. Yeah. And that was the last problem on the final exam. That eliminated the A's right there. Yeah. There weren't many A's after that problem. I'm hoping somebody in here is going to try to integrate it. Yeah. And that is one big square root here. That denominator, all that's in parentheses squared. There's your 1. No, you can't just make that u. But that's, yeah, that was the integral that you would have to work. If you knew how to start the problem, the question on the test was prove that the circumference of a circle equals 2 pi r. That was the question. And to do the proof, as you're working through it, you get to this step, and you have to be able to integrate that. Yes, sir?
So say r is a constant, could you make r squared minus x squared your u,
Yeah.
and then negative 2x on top your du?
That's right, except you got a little problem here because you got that 1 plus it. So you'd have 1 plus a du inside, and that would still be inside your radical. And your du has never been inside your radical. See? Yeah. But that was the last question on the test. And the question was prove the circumference of circles equal 2 pi r. And so you had to realize you're going to write an equation for circle, x squared plus y squared equals r squared. And then you're going to take the derivative of it and you substitute the derivative into that formula that they gave them that you'd learned during the semester for arc length. And then you had to integrate it, and then you had to do the algebra after you integrated it. But you had to be able to integrate that. Yeah.
Only one person.
And the first thing I would do is I would divide out the -2's, right? And then after I squared it, what I would do is I would have square root of 1 plus x squared
And my top is only
over r squared minus x squared dx.
that is mine.
Find a common denominator and add those together.
I would
What'd you
jump
just
on
do
top
with,
of that.
what'd you just do with the 2? Divided it out.
Two, divide it out. And then I had a negative x and I squared it, which becomes a positive x squared.
Oh, okay, wait.
And I got a square root and I squared it. And then what you want to do is you want to get a common denominator for those two.
She was my number one.
So you'll get r squared minus x squared plus x squared over r
People
squared
must just be
minus
very
x squared
odd.
under a big bracket.
The people that are X's opposites, like,
Mine is, like, it's Olivia Boykin is on everyone's.
How'd you get x
I
squared
don't
on
even
the top?
know.
Okay, there's your x. Negative, so squared.
are you telling her mine? Did you see
You got
mine?
a fraction all in parentheses squared, so just square the numerator, square the denominator.
You're
separate.
gonna
This
laugh.
one makes me really funny because
Wouldn't that, like-
100% sure. But yeah,
Squares
mine-
is the problem to
mine
begin with.
49.5.
That square is in there to begin with.
Oh, it's in there to begin with.
Yeah.
Okay.
In my.
Oh, yeah, this is a formula that I gotta teach y'all to get into application.
Okay, I didn't know that's what.
Yeah, that's an application formula.
I thought you
And
just
it's really,
squared it.
this right here, this one is being squared too, but you don't have to worry about it because it's just a one.
I thought you just squared it.
No, you couldn't do that, you're absolutely right. That would mess you up.
That is two.
Yeah.
Y'all all just such higher percentages than I do. Like mine are in the 40s.
Her number 15 is 49%.
And all of y'all's are like in the 80s all the way through. That is too
And
funny.
you definitely your history.
No.
Josh Gordon, you can figure it out by the printout.
I don't know about rounding. This is funny.
Did you just combine them?
Yes,